Hello there, welcome to the June 2019 paper 1. Here we're looking at question 8. A scientist is studying the effect of introducing a population of white-clawed crayfish into a population of signal crayfish. At time t years, the number of white-clawed crayfish W and the number of signal crayfish S are modelled by the differential equations dw. We've got these equations here. Show that this is the differential equation when replaced for W. So what we need to do with this first equation is differentiate it with respect to t. So d squared w by dt squared equals, I'm going to expand the brackets while I do this, 5 over 2 dw by dt minus 5 over 2 ds by dt. Now the next thing I'm going to do is replace this into the part of the differential equation here, so I just get it in terms of w. So it's going to be d squared w by dt squared equals 5 over 2 dw by dt minus 5 over 2, and then it's going to be ds by dt, which is 2/5 w minus 90 e to the minus t. So let's expand the brackets now. We're going to get d squared w by dt squared equals 5 over 2 dw by dt minus, now these two fractions will cancel out here, so it's just minus w, and it's going to be a plus. Now I need to know what 5 over 2 times 90 is. That's going to be 225. So it's going to be plus 225 e to the minus t. Now I think what they finally want us to do is to times by 2 and move the w's all onto the left hand side. So therefore it's going to be 2d squared w by dt squared minus 5d w by dt plus w equals, now we have to, 2w, because we have to double everything, and then it's going to be double of 225, so 450 e to the minus t. So there we are, that's the answer for part A. Let's now move on to part B. Find a general solution for the number of white-clawed crayfish at time t years. So that means solve this equation here. The first thing we want to do is work out what the auxiliary equation is as part of working out the complementary function. So the auxiliary equation is going to be 2m squared minus 5m plus 2 equals 0. So let's put this into the polynomial solver in our calculator. That's probably the easiest way of doing this, rather than going through the whole process of solving it. 2 minus 5, 2. And that's going to give me m equals 2 and a half. So what that therefore means is that we could say that w is equal to a e to the 2t plus b e to the half t. And then we need to work out the particular solution. So given that it's 450 e to the minus t, I'm going to suggest that it's going to be some factor, say w equals some constant times e to the minus t. Luckily the powers on the e to the minus t aren't the same as the powers in the complementary function, otherwise we'd have to multiply it by t as well. So if we do dw by dt, that will give us minus c e to the minus c, and then if we do d squared w by dt squared, then that's going to give us c e to the minus t. Substituting it back into this left hand side here, so it's going to be 2c e to the minus t, that's the first bit, 2 times the second differential, minus 5 times the first differential, which is minus c e to the minus t. And then the last bit is plus 2 lots of c e to the minus t. That will equal 450 e to the minus t. So let's now cancel out all the e to the minus t's. and it's going to give us 2c plus 5c plus 2c equals 450. So therefore, it's going to be 9c in total, so therefore c is going to equal 50. So therefore, the general solution to this differential equation is going to be w equals a e to the 2t plus b e to the half t, and then it's going to be plus 50 e to the minus t. And there we are, that's our solution for part B, the general solution for this second order differential equation here. So part C is find a general solution for the number of signal crayfish at time t years. I think what we'll do is we'll pick out this differential equation here and then plug w back into it. But what might be helpful to know is what dw by dt is equal to. So that's going to be 2a e to the 2t plus a half b e to the half t, and then minus 50 e to the minus t. So now that we know that, let's now just rearrange maybe this thing in the box here. So it's going to be dw by dt equals, in fact, let's just times the 2/5 onto the other side, equals w minus s. So therefore s is going to equal w minus 2/5 dw by dt. Okay, so let's work that out then. So s is equal to w, and that first bit is going to be a e to the 2t plus b e to the half t plus 50 e to the minus t, and then it's going to be minus 2/5 lots of 2a e to the 2t plus a half b e to the half t, and then minus 50 e to the minus t. Okay, let's now simplify this. Let's have a look at the e to the 2t's first. That's going to be minus 4/5 and an a. So 1 minus 4/5 will be just a fifth. A e to the 2t. Oops. Then b minus, that's just going to be minus 1/5, so that'd be plus 4/5 b e to the half t. And the next bit's going to be this times this, so this add this, so it'll be double negative, so divide by the 5, times by the 2, that would make it 20, plus the 50, so that'll make it 70 e to the minus t. So there we are, that's the answer for the general solution for the signal crayfish. Okay, so moving on to parts D and E, the model predicts that at time t years the population of white-clawed crayfish will have died out. Given that w equals 65 and s equals 85 when t equals 0, find the value of e to the t, giving your answer to 3 decimal places. So I think first of all we need to work out what a and b are. So when t equals 0, w equals 65, so it's going to be 65 a plus b plus 50, so therefore 15 is equal to a plus b. And then on this side over here, if we plug in fact let's just do the workings on this side first. When t equals 0 for s, it's going to be s is equal to 85, so 85 equals a fifth of a plus 4/5 of b, and that's then plus 70. So if we take the 15 onto the other side, we get 15, 70 onto the other side, we get 15 fifth a plus 4/5 b. And we could spend some time rearranging this, or we could just plug it into the polynomial solver on our calculator, and we get a is minus 5 and b is 20. And you can always just check that on your calculator. So 20 minus 5, yeah, that's 15. And for this one here, it's going to be minus 1, and then 20 going in here, divide that by 5, will give you 4, 16. 16 minus 1 is 15. Yeah, lovely, good stuff. So those are our answers here. So therefore, Now we need to work out the time at which the white-clawed crayfish will have died out. So going back to this W equation here, W equals minus 5e to the 2t plus 20e to the half t, and then plus 50e to the minus t. We want to find the time at which that thing there is equal to 0 and there's no more white-clawed crayfish left. Right, okay, I think what we're probably going to have to do here then is set up some kind of equation, maybe turning this into a polynomial of some kind. I think first of all, just to make the highest power on e positive, I think we'll just times through by minus 1, just because that make it feel better for me. So that would be then minus 20e to the half t, and then minus 50e to the minus t equals 0. Okay, I think what we'll have to do is, if we try and set y equal to e to the half t, then we'll just see where that gets us. Okay, so therefore e, so it'd be 5e, no, not 5e, it'd be 5y. We're all turning all this into y. So e to the half t is y, so I need this to be to the power of 4. Then it'd be minus 20y, and then it'd be minus 50. But this is e to the minus t, so that's going to have to be y to the minus 2 equals 0. Let's now times by y squared, and we're going to get 5y to the power of 6 minus 20y cubed minus 50 equals 0. Divide through by 5, we'll get y to the power of 6 minus 4y cubed minus 10 equals 0. So now this thing needs solving, but it's not going to be an easy solution. I think I'll grab my polynomial solver from the calculator, and it's going to give me y cubed equals 2 plus root 14. Or 2 minus root 14, but we don't want a positive value for y, because we don't want a negative value for y, because e can't be a negative value. So it's just going to be this solution here. So therefore y is going to equal the cube root of 2 plus root 14. So therefore now it's going to be e to the power of a half t equals the cube root of 2 plus root 14. Then we'll get rid of the e by lunning both sides, so it's a half t equals ln, and the cube root actually we could pull to the front, so it will now be a third of 2 plus root 14. And then then times by 2, so it's going to be t equals 2 over 3 ln 2 plus root 14. And you work that on the calculator, and it says to 3 decimal places, and it is going to be 1.165 years. I think that's the unit of time there. Okay, so there we are. That's the answer for part D. Part E is state one limitation of the model. The limitation of the model is population could become negative if t is allowed to continue onwards, which is not possible. So something that means that the model is probably not going to be realistic. So there we are, that's the answer for question 8, a whopping 18 marks for that question there. Quite a big question there, but it is the final question in the paper. And that's the answer for the questions for Core Paper 1, June 2019. Maybe let's move on to June 2019, Core Paper 2. Thanks very much.